Right, there's the red button as always. Right, thanks everybody for joining the August community call. We actually have a pretty packed agenda today. So first, we're going to have a call for data partners from two of our study leads of the ongoing 2025 APAC studies. Our China colleagues are here to present their studies and ask the community to join their studies in terms of the core diagnostics that's being prepared. Followed by regional mid-year updates that we missed from June last time. So Australia and Malaysia's leads are here to present their updates. Followed by, we're going to have a deep dive session on OHDSI, some of OHDSI India's developments that were shared back in June as well. And last but not least, if we have some time, I'll be providing some updates on the 2025 APAC Symposium so that you guys are aware of what's the latest status and what are currently open for you guys to take part in. Awesome. First, we're going to do the call for data partners. We're going to have Yongqi from Peking University to pitch his study and do a call for data partners. Yongqi, over to you. Let me know when to flip the slides, okay?
Okay. And so, hi everyone, this is Yongqi Zheng from Peking University. And today I'd like to briefly introduce our multi-database observation study and invite data partners to help run the cohort diagnostics and, if feasible, participate in the subsequent analysis. Next slide, please. For type 2 diabetes, metformin remains the fundamental first-line therapy. GLP-1 rates are increasingly recommended, either as monotherapy or add-on, for patients with established CVD, CKD, or obesity due to their cardio-renal benefits. However, there are safety concerns related to delayed gastric emptying, including potential risks of gastroparesis and intestinal obstruction. The current evidence is conflicting. Some large observation studies reported increased risks, while others did not. And no RCT has specifically targeted these GI outcomes for GLP-1 rates. This motivates the need for robust real-world evidence, ideally across multiple databases with consistent cohort definition and diagnostics before estimations. Next slide, please. Our primary objectives are to compare the risks of gastroparesis and intestinal obstruction among new users of GLP-1 rates versus DPP-4 inhibitors and SGLT2 inhibitors. As secondary outcomes, we will also assess acute pancreatitis and NAFLD to provide a broader view of digestive system safety. Next slide, please. And our study structure is that exposure to GLP-1 rates have a different risk of experiencing gastroparesis or intestinal obstruction within the end of continuous observation relative to DPP-4 inhibitors or SGLT2 inhibitors among the population with type 2 diabetes and history of metformin. We focus on adults 18 or older who have type 2 diabetes, who have at least 1 year of prior observation, and who have at least 90 days of metformin use before starting the study drug. We exclude anyone with T1DM or secondary diabetes, anyone who previously used one of the study drugs or initial combination anti-diabetic therapy, anyone with prior insulin use, and anyone with a history of pancreatitis, digestive system cancer, or abdominal surgery. We also exclude patients with renal dialysis, kidney transplant, or end-stage kidney disease. The study uses a new user active comparator design. The target arm is people who start a GLP-1 race, and the comparator arms are people who start a DPP-4 inhibitors and SGLT2 inhibitors. The primary outcomes are gastroparesis and intestinal obstruction. The secondary outcomes are acute pancreatitis and nephrite. And next slide, please. And all links and contacts are listed on this slide. You are very welcome to join and run the cohort diagnostics with us. And thank you for your considerate participation. And that's all. Thank you.
Thank you, Yongqi. For those of you who don't know, we have bi-weekly meetings for this specific study. Next one is coming up next Tuesday. You're more than welcome to join us at the Teams channel. Thank you, Yongqi. For purposes of time, I will hand over to the floor to Cheng now so that she can provide a overview of the study from Fudan University. Cheng?
Hello everyone. I'm Jing Chen from Fudan University. Today, I'd like to introduce a multi-center study led by Jing. This study used the OHDSI framework with standardized analysis methods to explore how fasting plasma glucose levels relate to the number of hospitalization days. I divide today's presentation into 3 parts. Next slide, please. First, let's talk about the study background and why it matters. LPG level is a key indicator of metabolic health. Past studies have shown that abnormal LPG levels, whether too high or too low, are linked not just to diabetes, but also to other health problems like inflammation, and they can exacerbate chronic diseases. These problems can lead to more hospital visits and longer stays. Next slide, please. However, there is still a lack of large-scale multi-center research that systematically looks like how LPG levels relate to the local number of days patients spend in the hospital each year. There where our study comes in. Our goal is to provide scientific evidence for better blood glucose management and the smarter use of healthcare resources. Next slide, please. The second part is about the study design and the methods. Let's start with who we are included in the study. First, patients must be 18 years old or above, regardless of gender. Second, they must have a record of LPG measurements during their hospital stay. This measurement needs a validated number, a timestamp, and be in either milligram per deciliter or millimoles per liter, and LPG can't be 0. Also, patients need complete hospital records, including both admission and discharge dates. Additionally, they must meet at least one of 2 extra criteria, either they were admitted to a specified clinic department or they have had more than one hospitalization episode. Who will we exclude? Patients with incomplete hospitalization records or those whose hospitalization dates far outside the past 5 years. Next slide, please. We have constructed 2 study cohorts using OHDSI standardized tools, which include relevant concepts, one focusing only on LPG data, and the other on glucose measurements taken during hospital stays. For example, we'll look at patients who have at least one LPG measurement in fixed continuous observation period starting from the event and analyze their medical history characteristics. We'll also look at patients who had an inpatient or ER visit accompanied by a glucose measurement during the same clinic encounter and check their medical history too. Next slide, please. We'll use OHDSI cohort diagnostic tool to make sure the data we use is suitable. You can find the cohort definitions for our study on the OHDSI website. The cohort diagnostic package we use is available on GitHub. This study relies on real-world data and we need your help. If your institution has electronic health records, especially record with LPT measurements and the lines of hospital days, we'd be thrilled to have you join this multi-center study. If you have questions or want to collaborate, you can send resource or ask for technical help via this email. Our team will put together all the analysis results from different centers. That's the end of my presentation. Thank you all for your attention.
Thank you, Cheng. Like the picking study, this study also has recurring study meetings. Next one is coming up next Wednesday. Yes, Jiwon.
Thanks, Cheng and Yongki, for your presentation. I was just curious about what scope the results the study teams are planning to present at the symposium. Is it gonna be just core diagnostic package or your original protocol? I was just curious about that.
How about I answer that? It's really as far as we can get. Right. So the objective is, of course, we want to, if we can achieve their ultimate study objective, that would be great. But as we are all learning this for the first time, especially those in China, how to do this, I don't think that's going to be achievable for all three studies. So thus, it's really what we want to showcase at the symposium is what we've done and how far we've gotten and what the experience has been. Right, the journey itself, to talk through the journey itself, right? So, but of course, after the symposium, we would still want to continue the studies to get them to where they are.
Yeah, got it. What about USTC? Are they gonna share their PLP or PLE results?
They haven't gone that we had to, so there were issues with the way they had it designed. It wasn't designed in the OHDSI way, so we've been working with them to redesign it to in the OHDSI way. So that one's a little further behind, although they were more advanced because they even have Python code written already, right?
Yeah.
But again, an OHDSI study, we want to make sure it has the OHDSI foundations in it. So again, they will be presenting everything that we've learned thus far is always good experience and a good journey for everybody to talk through, right?
Sure.
So again, for all three of them, it's going to be how far we've gotten.
Great. Thanks, Molly.
Cool. All right, the slides will be distributed on odyssey.org for the URLs for the specific core diagnostics package that were shared today. So for those of you who are interested to join, please do check out the upload that's going to be available on odyssey.org's APAC community call page. All right, that's all for the APAC studies call for data partners. We're going to move on to the regional chapter mid-year updates from Australia and Malaysia. Over to you, Nicole.
Excellent. Thank you, Song. I will share my screen. Hopefully you're seeing my slides.
Yes.
Okay, so I just wanted to give a very brief update of where we're at in the Australian chapter. I apologise we weren't able to come along to the previous community call where other chapters updated the community. However, that was for a really good reason. We were in the middle of organising with a funding institution the creation of the AIDEN collaboration, which I'll talk to you about in just a little minute. So just really briefly, there's been a lot of activity in the Australian chapter on the ground, so I don't have a lot of things to actually tell you about, but there has been a specific focus this year on looking at data security and looking at data frameworks and privacy and use of sensitive data. So here are just a couple of presentations that the OHDSI chapter has been involved in. And these were both led by, one of them was led by myself and Roger Ward, and Roger Ward also presented in the Trusted Research Environment session that was held here in South Australia. So there's been a lot of focus on use of sensitive data and how we might use them appropriately. What are some of the restrictions around the use of Australian data in particular, given our legislation, and the ways in which things are done uniquely in Australia, I will say. So that's been a big focus for us, and particularly trusted research environments have now become a very important tool in Australia, and there are lots of different ways of setting up trusted research environments and different mechanisms. So we had this presentation, Roger was talking about the Australian, the ARDC approach to TREs, but we also had lots of international colleagues come and tell us how they do it in their jurisdictions. So that was a really informative presentation. So that the whole series of presentations is available on YouTube at the Health Translation SA channel. And so there was a really interesting talks by lots of different people. So if anybody's interested in TREs and how they're set up and the different ways of doing so, it's a really good presentation to watch, and it's all available on YouTube. So that brings me to the AIDEN network. So as I mentioned, we've just been successful in having this project funded for the next 3 years by the Australian Research Data Commons. The ARDC is an Australian government department or institution, and they provide research funding for infrastructure. So lots of different types of infrastructure, medical research, but also, environment and, global ecology and water and a whole heap of things. But the ARDC have been amazing in funding the ARDEN project. ARDEN itself is shamelessly borrowed from the EDEN project, so the European Health Data Evidence Network. We are called the Australian Health Data Evidence Network. And our vision, like many collaborations in OHDSI, is to enable a future where health data, particularly across Australia, can be harnessed to generate rapid, high quality insights to drive better health outcomes and support decision making. So what does ARDEN look like? So we have 5 pillars of activity that we will develop along our 3-year timeline. And the first is of no surprise to you online, which is standardizing data to the OMOP common data model. So what ARDEN will do in the first instance is to harmonise the translation of hospital-based electronic medical records across Australia. Many of the states in Australia are now moving to a single electronic medical record system. So a vendor in each of the states. And so the idea is to sort of harmonise those across the different states. And we will then be able to interrogate data for the whole of a state or, different hospitals within that state. So ARDEN will help to, facilitate that. The next pillar is around research. So obviously we want to start to build collaborations across these states who all now have data translated to the OMOP CDM for the purpose of generating evidence that is of high value to hospitals as well as state health departments who are sort of jurisdictional owners of those data. The central pillar, of course, as always, is capacity building. So while we're doing all of this activity in terms of translation and in terms of research, what we want to do is upskill researchers and, data custodians on the use of OMOP across Australia. So we will be developing a large capacity building program, which will take the form of educational resources, but also lots of in-person study-a-thons and that kind of thing, similar to what many other chapters do across the world. Next, fourth pillar is around federated services, and what we mean by this is really developing tools that are consistent across Australia and are built for Australian standards, for example. So a lot of the federated services will be around harmonising vocabulary translations, specifically for Australian vocabularies, looking at federated tools for analytics that take into account the Australian healthcare system, that kind of thing. So I'm really trying to harmonise some of those tools and services that are specific to Australia, leveraging what has been done internationally, of course. And the last pillar is about policy and advocacy. And this is really a communication pillar where we're trying to really, communicate the role of OHDSI in terms of generating evidence for policymakers and decision makers, regulatory authorities, as well as clinicians as well. So there are sort of 5 central pillars. I won't go through each of these, but we have developed a series of workstream activities under each of those pillars. And again, no surprises in what we're trying to do there, really trying to uplift data, uplift researchers, build capacity, generate federated analytics and federated services to help, progress OHDSI Australia's mission. So that's me very quickly. So thanks, Dong.
Thanks, Nicole. Great news to see a nationwide movement in Australia, although you said it's shamelessly mimicking Eden. I think it's a good model to follow, right? Especially if you need to persuade the government on any use cases already with that model. So excellent, great news. I'll now hand over the floor to Stephen, and then maybe we'll just open up the floor for a few questions before we hand over to Shweta. Cynthia, can you hold your question? We can do this after Stephen. Yeah, over to you, Stephen.
Okay. I have to say that I am the one that shamelessly showing just some blank slides. Okay,
no, you're here, Stephen. That means a lot. Thank you.
I have just a few 4 points to highlight. And the next round, I will try to make it a point to bring the stakeholder in the respective organization to come and share a little bit more, given the fact that, I can't, I'm not authorized to show all the slides that we have created for them. And so somewhat I'm just making it very, very simplified. Some of the key updates, the things that we are working on in Malaysia. Number 1 is related to private healthcare, KPJ. KPJ is the largest healthcare organization in Malaysia. They have already decided to embark on OMOP CDM. So right now, it's in the process of bringing data into the central data lake and making the next step, bringing it into OMOP CDM. And they have a very interesting initiative whereby they are trying to actually converge the hospital operation with the clinical and research and education together as one. So that will actually research outcome together. So that is really, really nice after all the demonstration, the piloting, and finally they have made a split. Second one is actually the MyGenome. What is MyGenome? MyGenome is actually a Malaysian genome project, and still at the very, very beginning stage, whereby they are bringing together 2004 healthy individuals and later on move to 10,000 genome in phase 2. So this is already ongoing. Their intention is really to drive towards the precision medicine, and hence we have introduced to them the old concept of CDM. They see great relevancy, especially expanding its capability in the area of pharmacogenomic. And the next step, what they are trying to do is while they're working on their phase 1, they're also trying to start building internal capacity, and will be reaching out to some of the community, especially the oncology work group, who have a lot of experience in bringing data, genomic data into OMOP CDM, and see how it can be stitched together. For example, how it's stitched together in the measurement table and so forth. So that is something that they are planning to do. We're planning to do together. So the next one is NIH. I heard a lot about, Nicole was talking about TRE, and that's really interesting because NIH Malaysia is embarking on TRE. This moment, at least, it is in principle already been approved. Now they are working on the funding. They are, of course, Australia is still a lot ahead of Malaysia in the funding process and everything else. So we are taking the step by step, and hopefully we can learn from the experience from Singapore and also from Australia in making this happen. So NIH is also sending one of the key person, Dr. Fadli, to Singapore to work with people like Morning and potentially talking to people from trust to actually get a good idea of how to go about setting this up. I think sometime next month or a month, October or November, somewhere around that. And Ministry of Health currently is embarking on digitalizing clinics across the country with the same solution, with the same clinical software, so primary health software. While they're doing that, they're also planning to start connecting to the central data warehouse, and central data warehouse will then be fit into OMOP CDM starting from Q1 next year. So they have already digitalized about more than 100 over clinics with the same software, and then they plan to actually grow it to, I think they have 1,000 or 2,000, around that 1,000 plus clinics to be digitalized across the board, across the country. So these are some of the initiatives, but of course, putting in the OMOP is one thing. The enabling side is where it is going to get very exciting. That is when the capacity, the NIH and MOH will have the capacity to participate in some of the research among themselves, and also with among the community, participating with the community members as well. So that is something that we are really looking forward to, and they see this as some of the very critical steps moving forward to advance the healthcare in Malaysia. Thank you. That's all from my side.
Thank you, Stephen. Great updates from Malaysia as well. I think this model of top-down approach where government starts moving things around OMOP is actually a very good approach. It works in a lot of countries, including Korea here, where it's already being done over the past few years. I know there were several hands up here and there. Cynthia, maybe you first. You had a question for Nicole?
Yeah, I'll wait later. Go
Okay.
ahead to the next person.
That's all, Cynthia. We're going to move on to India, but yeah, just wanted to open up the floor for the two regions.
Oh, okay. I just wondered how much the Australian government is putting in to fund the Australian ADN.
Yeah. Well, I mean, when you say putting in, the ARDC, the Australian Research Data Commons, is actually a funded research enabler, I guess is the word you would call it, from the Australian government. So they're actually affiliated with the Department of Education. So it's very much, the strategies at the government level. So that's where the funding is coming from. The funding is also coming from in-kind support through some of the states as well. So yeah, that's kind of where that funding comes from, not directly from government, but it is supporting it.
I see. So, but I guess just what is the quantum? Like, is there like when you've budgeted out everything, what's the cost? Just I'm trying to get a sense of that, like for Africa.
Well, I might need to talk to you offline. I'm not sure I'm
okay
at liberty to talk about that. But
okay.
I can certainly talk to you at least the model that we're using. So yeah, more than happy to chat with you offline,
Okay.
Cynthia.
Okay, thanks.
I was all ears too.
I got a quick question to Stephen. I just want to ask how many different racial and ethical groups in Malaysia? How many? Like, I was just curious during your presentation. How many racial and ethical groups in Malaysia?
Oh, actually, there are many. You're saying racial groups?
Yeah, racial and ethical groups.
And
Ethnic group.
actually, it depends on how we classify it. Right now, there are two standards. One is you're going down to very low level. For example, up in Sarawak, one of our state, we have a lot of aborigines and different kind of ethnic. You're referring to ethnicity groups, right? Are you referring to ethnicity?
Yes, race and ethnicity. Yes.
Okay. Yeah. There are many small tribes or Aboriginal groups.
Oh, okay.
There is another
That's
type that is on a more holistic perspective. It's only broken into four: Malay, Chinese, India, and others. So there is a more generic one. But actually, there are another type where it's broken down into very sub groups where we understand their Daya and all those smaller groups.
Okay. I was just drawing the question regarding that My Genome project that you mentioned before, because in Korea, in my perspective, in Korea, we just have one race and ethnicity. So just want to curious, like how many different groups you guys have in Malaysia. Thank you, Stephen.
Cool. For purpose of time, Karthik, your question is going to be the last one. Go ahead.
Damn, managed to sneak one in. All right. Hey, Nicole and Stephen, great sharing. Thank you. I mean, I'm asking Nicole this one, but I guess I'll reach out to you separately also, Stephen, about this. Nicole, is the partnership that you are doing for Aden sort of fixed already, or are you open to new people reaching out to see what they can contribute towards this initiative? Because we would be super interested to be part of this.
Yeah, well, I mean, the collaboration is specifically with the states in Australia. So that's kind of set. But in terms of collaboration, more than happy to chat with you. One of the things we really want to do is generate some use cases to demonstrate the value of doing federated analytics across hospital-based EMR systems across Australia, and would be calling for collaborators to be involved in that if they wanted to kind of get involved. So let's chat offline a bit more about all of that. But in terms of the partners and the funding, that's kind of set right now. Okay. But if there's probably other opportunities, and just like Eden has done and other collaborations have done, we really want to springboard off this infrastructure build and this infrastructure money to develop research funding for use cases. And that's, I think, the model that many people have used. So there's so much opportunity in Australia and externally for funding applications to fund the use cases and to fund the evidence generation. So we're more than happy to talk about those opportunities as time goes on. Yeah.
Right, perfect. I'll reach out to you separately then.
Great.
Thank you. Thank you for letting me ask that question, Gil.
No problem. Thanks everybody for the questions, interactive session so far. I'll hand over the floor now to Shrita, who's going to talk about some developments in OHDSI India more in depth on what was shared versus what was shared in June last time. Go ahead, Shrita.
Thank you. Thank you so much. Is my screen visible, you guys?
Yes.
Hi all, and this is our agenda. There's an which is a small overview on the breast cancer study that we are currently doing, and an FHAR work group that we have initiated in India, and the CBD patient registry that we have built, and the Digital Health Center of Excellence. We are looking for collaborations. So this is our team. Hey guys, I think everybody is here. Can we see some thumbs up and all here from everyone? Yeah, this is me, Dr. Shweta, and Kanza Fatima, Sai Dilip, Shrima, Sanjay, Pattabiram, and Vipina. This is our breast cancer study team. So regarding breast cancer study, as we said, Indian data is mostly unstructured and semi-structured data. Even EHRs and the EMRs in place as of now started kicking off, but still we expect a lot of data, even partially 50% of data will be unstructured and semi-structured. So we thought, let us start with applying some NLP technology and text extraction and get some standardized data from that and understand how we can map Indian drug brands and clinical text to UMAP concept IDs, and let us start with it. So we have started with the breast cancer study with the discharge summaries that we have found in JSS Mysore University from 2014 to 2022. Our main objective is to standardize the data, extract with the NLP techniques and convert the data to UMAP standards, and then see if we can generate some kind of real world evidence and generate good studies from there is our objective. So this is our data. This is a small discharge summary, a sample discharge summary, and this is a dummy discharge summary we have placed here. So what we have exactly in the data, we have some kind of demographic information of the patients. That's the age when the patient is admitted. These are all the inpatient discharge summaries. So description of what is the current diagnosis and what are the current symptoms of the patients, what is the medical history of the patient, the labs and diagnoses or the procedures that are performed during the inpatient visit or any past history of procedures done on the patient, and the course in the hospital, whatever treatment was given, whatever drugs are given to the patient, and also advice on discharge summary, like a discharge, what kind of drugs were prescribed to the patient. So this is the basic information we can get out of this and extract. So this is about our data and process overflow, like how we have framed the pipeline or what are the steps we have done along this way. So we have PDFs, so we have directly de-identified the PDFs to remove the patient health information, and then we have converted all the PDFs to text and then manually annotated 500 to 600 discharge summary to create the training data set. And we have developed NLP models for named entity recognition and relationship extraction and concept normalization, and evaluating the model with precision recall, F1 score accuracy, and OMUP CDM data conversion. These are the process overflow steps or pipeline that we have found. And the first step PDF de-identification, mainly to remove the PHI. This is how we have done that, and we have used a simple redact tool to do that, where re-identification is not possible, and the tool was about 100% able to remove all the patient health information from and this is rechecked by the team in JSS to share us the data with. And then conversion of PDF to text is done with simple Python script, and annotating the clinical notes is a primary task which is done manually. So as a first step, we have developed annotation guidelines. We have identified the main entities. There are five main entities we have observed. That is the demographic entity, the problem entity, procedure, drug test. And we have described in the annotation guidelines what each entity means. And for example, if we have taken the problem entity, each entity is described with its modifier. Like problem entity, what is the severity of the problem, and what is the body location, temporal negation, like giving no, this a kind of negative phases, identifying it, and the problem status, like whether it is a current status or the history of the patient. So these kind of modifiers and relations we are able to give in this annotation guidelines. So this is what we have covered in the annotation guideline. That is the basic annotation rules, like what is gender look like in the document, how they have to annotate it, what is age looking like, and how to annotate it, and specific guideline for each main entity with examples we were able to give, and special cases, how to identify the special cases, what are different conditions they have to remember, and the modifiers, almost 25 modifiers we identified and described and given examples, and how to build the relationships. So this is what it is there in the annotation guideline. This is how the annotation look like. We have built an annotation schema with all the main entities and the modifiers. And for example, there is a procedure chemotherapy. It should be manually annotated as a chemotherapy. And if there is a modifier for that, like a diagnosis is that LLDC, left breast, and left breast is identified as a condition as well as a body location modifier. If there is a Dromstol and the tablet is identified as a form, and the strength is 10 mg and frequency and the duration, we have to identify and give relations to that. This is a basic annotation structure we have followed, and the tool we used for this is Medtator tool, and here is the GitHub link, and we have done this annotation in 4 batches totally. So we have maintained a consistent 94% while doing it, and 25, 75, 75, and 125. This is the batches we have released for each inter-annotation agreement actually. So how this inter-annotation agreement works, we are giving here. This is the measurement we have used. Cohen's kappa and Krippendorf's alpha is something we have used, and this is used with Medtator itself. It was able to calculate with that. And if the annotation guideline, we have to follow the annotator guidelines, and then annotation is done. Then if it is good, it will go to the annotated data set. If it is bad, then we have to analyze where we have done wrong, and we will be redoing the annotations. The overall score, F1 score, we are able to maintain 0.88%. Coming to the next step, developing NLP models like named entity recognition and relationship extraction and concept normalization. This is a data extraction from the discharge summaries, what we have done, and the named entity recognition, as I said, it is like 5 main entities and 25 modifiers, 25 to 27 modifiers. And with respect to relationship extraction, giving the relationships and all these things we were able to extract with the word model, and concept normalization and vocabulary mapping. We have faced a lot of challenges. Maybe in the coming slides, I'll explain how we have done that. And the train, validate, test data ratio is 70, 10, and 20. This is what we have followed. Named entity recognition, we have developed a BERT model mainly to identify the boundaries of entities and semantic categories of the entities. We have followed the bio-tagging, beginning inside and outside tagging, and I have attached a screenshot how this tagging is done for a demographic entity for more clarity. And for example, the evaluation is done if there is breast cancer. The breast cancer should be identified completely as such as BI, then it is an exact match. If it is cancer, the cancer is only identifying, then it is a relaxed match. And if breast is identifying as a body part, it's not a match. That's how we are able to evaluate it. And then relationship extraction. This is also done with the BERT model, mainly to identify the semantic relationship and context of the relation. So carcinoma breast, it has an attribute related to that. And bronchopneumonia, which is a final diagnosis, it has an attribute. So the relationships, whatever we have manually given, the model has to be identifying that. So this is the evaluation part. The red line represents the drug has a frequency, and the blue line represents negative. There is no relationship with it. And for concept normalization and vocabulary mapping, this is work in progress, like work, I would say. So the entities, whatever we have received from NER and the relationship extraction, we are generating synonym generation models, mainly to reduce, like, for example, carcinoma of breast cancer, cancer in the right breast, cancer in the left breast. There are many context used, synonyms used while writing the discharge summaries, because it's from 2014 to 2023. There are different variations of that. So we are even able to use Elasticsearch. We have built a tool which is like a medical mapping tool, mainly for the Indian context, where we are able to identify these synonyms or normalize it and do manual validation, like depending on the frequency, like something like SAGI, and we can validate it and give a concept ID to this. So give a concept ID to this. So this is what we have done. And so this is a concept normalization for clinical texts and drugs. We have used UMLS API, where manual validations we made sure we have done for each vocabulary mapping or clinical node, and then converted it to UMAP concept ID. And the main dictionary we have used is UMLS. And then for drugs, we had an ISO SNOMED work group 6, where they are building like mapping all the Indian drugs to SNOMED codes. So we are able to identify the flat files, and also we are connecting with UMLS, and we are converting these brands to the generics where if it is the direct brand is not available in the RX now, and we have converted it to UMAP concept ID. So this is about the medical mapping tool that we have told. We are trying to train 2 lakhs drugs from Indian data, that the brand names should be converted to generic composition. And like this will map like UMLS, RX norm, and SNOMED CT, whatever the clinical text, or it can be Indian brand names to the generics. And we used Gemini AI in this, and like the manual reviews and auto spell checks, the abbreviation recognition, all this is possible with the large data sets. So this is a small input I have attached how this tool works. For example, the drugs, some short drugs I have tried to upload in this tool, and this after doing the manual like validations, this is the output we receive. It will map it to CUI, and the source code, it will map it to RX now as well. This is the output from the tool. Coming to the last step, OMAP CDM, these are the tables we assume that we convert the data to, and maybe in another 2 months, I will give an overview on what scores we were able to achieve, what is the evaluation results. And these are the tables like percent table measurement and conditions and observations with SNOMED CT, and drugs with RX norm, and the node table. So what we have learned in this complete exercise, it's like de-identification and like text extraction of the 5 main entities, and 25 modifiers extracted, like temporals and the drug frequencies, doses, and different kinds of diseases, diagnosis, and contextualizing the past versus the current condition depending upon the discharge summary date. And mapping mainly the Indian drugs or clinical text to UMAP concept IDs. And we were able to build a tool not only for the studies, even we are building future studies, it would be easy for us to convert the data. So the realities of research, or the challenges, what we have faced, what are we going through? So the primary thing is very stringent data privacy rules. The data partners are not open. Even though we have almost 180 people in our team, such as OHDSI India collaborators, and many people are coming forward to help us in studies, we are able to use all the collaborators because the data partners are not open completely because of the data privacy laws, to even as the federated nodes or placing the data in cloud and building these models. It is very tough for us to convince the data partners. So a very small team is working for all the complete work, and we are able to predict the infrastructure needs, because NLP needs a huge infrastructure, and we are not supported by any of grants or anything as of now. And the GVW is our own source of financing our budgeting our needs. So this is very tough to get approvals, and this takes us some time to get it done. And it is resource intensive. As I said, we are a lean team. You have seen our team, and manually annotating and mapping the vocabularies is very tough for us. We need a lot of resources for that, but we are doing with a small team. We are doing it. And Indian drug data mapping, mainly with the brands to the RX norm or generic, is a tough task, but still we are trying to convert that at least 2 lakhs drugs. We want to do that in that way. That's our aim to do. So the next steps from this breast cancer study, we want to do a publication out from this study, and then automate the process. For sure, we are going to get unstructured data and semi-structured data even in future. For few years, we expect such kind of data from Indian hospitals. So we want to automate some kind of process at least in between, and to give JSS and some more researchers access to the converted data and see how Atlas is working with our kind of data. And opportunities mainly for breast cancer data, we want to see some networking and collaborative studies to increase the data set size, and we want to train and expand our medical mapping tool for wider community use. So these are our next steps with respect to breast cancer data. And these are few preliminary research questions we thought to apply for once the data is converted. A simple characterization study with demographic profiles, common comorbidities, procedures, drugs and tests, whatever entities we are able to extract from, and the treatment patterns, and the predicting the length of the stay of the patient, and also a baseline demographic and clinical features predict whether patient will complete more than 6 chemotherapy cycles, because we see a lot of cycle numbers over the discharge summaries we would like to see. But the important research questions will come after our first characterization study. We will understand what data is there, what we can do further with it. So this is one more initiative that we are building in India. So FHR work group, we have collaborated along with the HL7 team. Kumar Satyam is a person who's chairing the HL7. We have collaborated with them, and Dr. Chandal, who's a co-founder at SVM Hospital, Manish, a founder in Yazur Healthcare, Parthiban, we all know Parthiban, and Shweta, it's me. So we are trying to build some kind of ABDM FHER, Ayushman Bharat Digital Mission. We have adopted FHER, but it is something not really the complete FHER. We have tweaked it for our needs actually. So we want to map that to UMAP conversion and see how far the global FHER guidelines can be adapted. And we want to do a small study or small kind of exercise on that. And advanced capacity building and community engagement is something we are looking for. And they are almost 2,000 current HL7 team they are. So we are expecting a good number of collaborators along with that. These are all current collaborators. We are going to form a very good work group is what our thoughts are. So this is about FHR. And the second initiative is the CVD patient registry that we have built. As we are evolving and into the digital mission currently, patient data collection itself, it is a kind of, we want to see by building an OMAP competent patient registry and see how we can build a longitudinal database collecting only for CVD for a particular department, because this department, the patient's inflow is more in different hospitals. So CVD, and it's a therapeutical area where the national interest is also there. So we have built a registry. You can see on the image like demographic information, the diagnosis, drugs, the procedures, everything can be noted here. And we have applied some predefined fields where it is coded automatically to the medical dictionaries we have integrated. And then we are trying to convert to automate the process of home conversion and we want to build a capability of ABDM FHR readiness. Phase 1 is ready for it to release, and phase 2 will be with the FHR ABDM readiness. So this is about the CVD patient registry. As of now, like this will be for release, and like we want to extend it to other therapeutical areas as well. So this is the other initiative, that is Digital Health Center for Excellence. As I said that India is moving towards the digital mission. ABDM is an important structure that we are building in, and we want to align with the national interest. We want to know what's exactly happening, and we want to unlock the potential of large scale health data in India to enable the RWE studies. So with this aim, along with Ashoka University, Rintu Kutam is one of the person who is supporting us, Parthiban and me. We are trying to collaborate and form a COE with various hospitals, identifying and understanding their needs, and maybe different aspects we would like to bring, and mainly to see some fundings and grants from the government and other aspects to see how we can go through that and gain some grants and mainly money for OHDSI India. So this is our journey, and please join our India chapter to support us. And we have our LinkedIn, YouTube, and we are active there. Looking forward for more questions. Yes, please. We are done with this.
Thanks, Shrita. I hope you didn't rush through. You're right on time. But yeah, I hope you didn't have to go through quickly just to meet the time. Any questions for Shrita around the news from India? I have a few questions, Shrita. So in general, so for the breast cancer one first, right? In general, you're using various models available to somehow extract relevant information from unstructured data to make those data available for conversion into the OMOP aspect, right? So you did address a lot of the data cleansing phases on cleaning up the data from unstructured notes. I guess my question is how straightforward is so you've extracted the relevant information that you need to populate a OMOP common data model, the data model itself. How straightforward is that conversion to the OMOP data model? Have you not reached there yet, or is it working well? I guess is my question.
It is working well. We are almost done with the named entity recognition, and also the relationship extraction, and 85% model performance has done with MER, and for relationship extraction it is 75, and we are trying to improve more. And with respect to like this concept normalization, our tool is working very good, but we are trying to build a kind of automatic model in between, so that the last option will be it's like a layering. We want to try some 2 layers. First will be a model built, and then for concept normalization and synonym identification, and then we will use the tool what we have built to normalize it. That's where we are. We are in the 3rd step, I would say, and then OMOP extraction, but ETL scripts are parallelly we are writing, and then like maybe another 2 months is what we are expecting it to complete and come up with some results.
Cool, sounds good. I have other questions, but I'll open up the floor. Nicole, over to you first.
Yeah, just well done, Shrita. That's a lot of work. Congratulations. Maybe I missed it, and I apologize. Are you thinking of also, because you're using the breast cancer example, are you also populating the oncology extension part of the CDM, or is it just the CDM? Yeah.
As of now, it is just the CDM that will be we are aiming to, but we are planning to do the extension as well.
Okay.
That will be our 2nd stage, I would say.
Yeah, that would be amazing.
Our expectation is, please let the data be in OMOP structure and see what we can see from there is our excitement.
Yeah, fabulous. Great. Thank you.
Thanks, Nicole. Cynthia?
Yeah, really nice work.
Cynthia.
Hi, Shrita. Yeah, this reminds me of some work that I did a few years ago with trying to extract adverse drug reactions from, unstructured notes, but the best we ever got was like 75%. Like
Okay.
so the 90% inter-observer agreement is like fantastic. And I guess, is that because you have the help of an AI engine?
No, you're asking about IAA, inter-annotation
Didn't you have
agreement?
like 95% or
That is
97%
for inter-annotation. 95% is for our inter-annotation agreement, and NER and the other relationship extraction, NER is at the range of 85%, and relationship extraction we are at 75%, and the concept
Okay.
normalization, our tool is recognizing 70% at this time, but we would like to train it more and make it more improved version. Yeah.
Yeah, well, I realize how much labor intensive. I mean, I think you went over it very quickly, but there's a lot of labor that's in here.
Yeah,
Congratulations.
Exactly. Thank you. Thank you. Yeah.
All right. Any other questions for Shweta? Right, we're 2 minutes past. Thank you, Shweta, again for coming on to give this great update. Very good to know. I'll steal everybody's time for 1 more minute. For those of you who have conflicts, feel free to drop off. But I just wanted to share a quick update on the APAC Symposium. So on the OHDSI.org website, there's this little button that's been newly created for the 2025 APAC Symposium. So this will be the event landing page like we always have for every year's symposium. And currently there's some preliminary information available with regards to the event, along with a high-level agenda, as well as more importantly around the collaborator showcase. So the 2 purposes of my pitch today is, 1, there is a landing page for you to refer to for updates on the event moving forward. But number 2, more importantly, we are currently receiving abstracts for the symposium in Shanghai. The abstract submissions are due September 7th. So we're already halfway into August, not many weeks left until September 7th. So just wanted to remind everybody, Collaborator Showcase is open for abstract submissions. The link is available in this form. So it will take you to a Google form, same old form you see all the time for both the Global Symposium and the APAC Symposium. Fill in the questionnaire as well as preparing your abstract in PDF format using this template, which is also the same old abstract format you always see in Odyssey. So please, everybody, reminder again that abstracts are due until September 7th. However, we are a flexible community. I'm pretty sure our leads and the scientific review committee will be more than happy to extend the timelines if people have last minute work coming in. So again, eye out on the symposium. Please do submit your abstracts on time if possible. If not, reach out to us for some late submissions, and we're more than happy to accommodate what we can. That's all I had to pitch. Mui wants to add something.
And remember, for the APAC Symposium, we also accept abstracts that's been presented at the Global or any of the other symposiums. Okay, so if you want to present some of the stuff that you've done at the other symposiums, we also welcome it here as well. So this way you don't have to write it again.
That's a very good tip, guys. So if you have anything you want to reuse, another opportunity to showcase your work. All right, thanks, Mui, for adding that in. And thanks, everybody, for staying on for additional 4 minutes. Great talks today and discussions today. Thanks, everybody. Bye-bye.
Thanks, everyone. Bye.
Ciao.